Today we're going to review for quiz number 2. This quiz goes through lesson 333. We're going to start with a domain and range problem. So here we have a graph. We want to find the domain and the range. So our domain, remember, are the x values, where the graph exists on the x-axis from left to right. So it starts right here, and if we go up and we'll see, well, that starts at -5. And where does it end? It ends right here, and that would be +1, 2, 3. So it ends at 3. So in the middle, we want all the x values that are greater than or equal to -5 and at the same time are less than or equal to 3. And then we have the domain of our graph. It goes from -5 to +3. All right, let's find the range. To find the range, we go from bottom to top. So where does the graph start going from bottom to top? Well, if you look right here, this is the lowest point of our graph. It starts at, on the y-axis, it starts at -2. So I'm going to put -2 here. And where does it end? Well, it ends up here at this point. And that is actually on the y-axis, so we count up 1, 2, 3, 4. It ends at +4. So we go from the lowest point of the graph to the highest point of the graph. Inside, we want all the values of y that are greater than or equal to -2, and at the same time are less than or equal to 4. So your symbols will always be going less than, because we always will go from the smallest to the largest. And there is the domain and the range of our graph. Okay, you might have another question. Let me just go ahead and turn the page. You might have another question that looks like this. Number 2, the directions will say solve for x. And they're going to give you an absolute value equation. Absolute value of 4x plus 3 is equal to 24. So the two questions you always ask yourself on absolute value problem is the absolute value by itself? Is there anything on the outside of it that's multiplied or added or subtracted? The answer here is no. It's the only thing on the left side of the equation. On the other side, we have a positive number. So if that number is positive, we are going to be able to get 2 solutions to this question. So in order to solve for x, I have to get rid of the absolute value signs. So I have to write my equation 2 times to get rid of the absolute value. First of all, I take whatever's in the absolute value and I set it equal to the opposite of whatever that number is. That's -24. Or I write it again and I say 4x plus 3 is equal to exactly what I see without the absolute value. And now I have 2 equations to solve, and that's how I get my 2 answers. So here I'm going to subtract 3 from both sides. I get 4x is equal to a -27, because when I add a -24 and a -3, I add them and keep the same sign. When I divide by 4 on both sides, I'm going to get x equals -27 over 4. I leave it just like that. Or I'm going to solve the other side. The other side, I'm going to also subtract 3 from both sides. And I get 4x is equal to 21. Well, 4 doesn't divide into 21 either. That's okay. Just divide by 4 and you get x equals 21 over 4. It's okay if you get fractions. Sometimes that happens. There are our 2 answers to this absolute value equation. So just remember, to get rid of the absolute value, you have to write it 2 times, once with the negative number and once with the positive number. All right, next page. In the next 3 problems, we are going to simplify. Number 3. Suppose you have x to the 5th times x to the -3 times x to the 7th. Now, there's a couple different ways we could do this problem. You might see that negative exponent and say, I'm going to move that to the bottom. Well, if you leave it alone and just add or subtract, because when you multiply like bases, you add your exponents. So really, I have x to the 5 plus a negative 3 plus 7. When I multiply like bases, I add my exponents. So I get x to the 5 plus a negative 3 is a positive 2 plus 7 would give me 2 plus 7, which is x to the positive 9. And you don't have to show this step right here. I just showed that to show you that, hey, I'm going to write my base and I'm going to add my exponents and simplify. All right, what about this one? Number 4, same directions. Suppose you have a monomial 6x to the 4th times y times negative 3 x to the 3rd y to the 8th. I am multiplying two monomials together. Well, I'm going to multiply my coefficients. So I have 6 times negative 3, which would be negative 18. Then I do what I did up above. I have x to the 4th and I have x to the 3rd, and I'm multiplying like bases, so I add the exponents. So 4 plus 3 would be 7. So I get x to the 7th power. Then I look at my y's. How many y's do I have total? Well, I have 8 y's here, and I have 1 y here. And there's really an exponent here that we can't see, so I could draw it in. So what is y to the 1st power times y to the 8th power? That would be y to the 8 plus 1, or 9. And that's as far as I can go. Multiply monomials, multiply your coefficients, and then you multiply your like bases, and when you do that, you add their exponents. Number 5. Suppose you have m to the negative 4th, and then you have n to the 8th. Now, these do not have like bases, so I can't do what I did up above. I can't multiply those together because I have m's here and I have n's here. So the only way I can simplify this problem is to get rid of that negative exponent. How do you get rid of a negative exponent? Well, my n to the 8 is not going to change because it doesn't have a negative exponent. It's going to stay right there. And to get rid of the negative exponent, I'm going to move it to the bottom and make it positive. I can't cancel anything again because my bases are not the same. So I have 8 n's on top and I have 4 m's on the bottom. And I'm finished. So that was simplifying with exponents. Let's go ahead and try a different kind of problem. Now this is one of the newer kinds we did. I think we did this last week. We're going to solve for the stated variable. I'm going to go ahead and turn the page. So it's going to say solve for the stated variable. Number 6. What if we have negative 8x plus 4y is equal to negative 20? And they want me to solve for y. That means get y by itself. Notice I have more than one letter. So I'm not going to be able to actually simplify the other side because I'm going to have an x over there. But that's okay. Draw a little arrow to the letter that you're going to solve for. We're solving for y. That means we need to move everything else to the other side. Well, the first thing I'm going to move, if I'm trying to solve for y, is I'm going to get rid of whatever's added or subtracted. So to get rid of that minus 8x and move it to the other side, what would I do? Well, I would do the opposite. I want it to cancel over here. So if I add it to one side, I have to do the same thing over here. My 8x's cancel out, and I'm left with 4y is equal to, I I can't actually add 8x and negative 20 together, so I'm just going to write 8x minus 20. Now, my goal is to get y by itself, so I still have to get rid of that 4. What is the opposite of multiplying by 4? Well, that would be dividing by 4. So I'm going to divide everywhere by 4. My 4's cancel out, and I get y equals 8 divided by 4, that would be 2x, and negative 20 divided by 4 would be negative 5. Notice what we have here. We have an equation that's solved for y. So it's in the form y equals mx plus b. So if they gave me this equation at the beginning and said, find the slope and the y-intercept, what would I have to do? Well, I'd have to solve for y and make it look like this. So I can tell that my slope is 2 and my y-intercept is negative 5. That's why we need to learn how to solve for a variable like this. All right. The next part, it's going to say multiply using the distributive property. I'll abbreviate that. Number 7. First of all, we have a monomial, and we're going to multiply it by a binomial. So when we multiply a monomial times a binomial, we have those parentheses, we got to get rid of them. So to do that, I'm going to distribute whatever's on the outside to everything on the inside using multiplication. So when I multiply right here, I have 5 times 3, that's 15. And what's x times x? X times x, they both have 1s as exponents, so I add them together and I get x to the second power. So 5x times 3x is 15x squared. Then I take 5x and I multiply by negative 2y. I get a negative. 5 times 2 is 10. And I can't actually put x and y together, but I can put them next to each other. So I get 15x squared minus 10xy. And I'm done because those are not like terms. I cannot simplify that anymore. All right, number 8, same directions. Suppose you have a binomial like 4x minus 5, has 2 terms in it, and we multiply by another binomial, x plus 3. We're going to do the same thing we did on number 7, except for this time we have to distribute twice. First, we're going to take 4x, and we're going to multiply it by everything on the other side in the parentheses. So here we have 4x times x, the 4 doesn't change, and x times x is x squared. Then you take 4x and you multiply it by that positive 3. That would give us a positive 12x. I'm halfway done. Now I take the negative 5 and I'm going to distribute that to everything on the other side. Negative 5 times x is negative 5x, and negative 5 times positive 3 is negative 15. Okay, now I have 4 terms, but if you'll look, these two are like terms. They both have x to the first power, so we can combine them together. Our 4x squared does not change. 12x minus 5x would be a positive 7x, and minus 15 does not change. So when I multiplied those two binomials together, I got a trinomial answer. Okay, a couple more. Next page. This time, it's going to say solve for x. Number 9. All right, what if I give you 24 is equal to negative 6 times x plus 8. I want to solve this equation for x. The problem is my x is inside parentheses. So the first thing I'm going to have to do is use distributive property and multiply that -6 times everything in the parentheses to get rid of it. So -6 times x, well, let me go ahead and recopy the 24 equals. -6 times x would be -6x. And -6 times +8 would be a -48. So notice I got rid of the parentheses. I now have a two-step equation. What do I have to do next? Well, I need to move this -48 to the other side. So I'm going to add it to both sides. And I get -6x is equal to, when I add these together, I get 72. Divide both sides by -6. My negatives cancel, so do my 6's, and I get x equals, my answer is going to be negative because that negative sign doesn't have anything to cancel with. And when I take 72 and divide by 6, I get 12. So my answer will be a -12. So here we're solving equations and using distributive property at the same time. Last one, number 10. What if you have 3 times m plus 2 plus 10, and 10 is not in the parentheses, is equal to 4 times m minus 2. So here's my equation. I'm going to solve for m. Of course, I guess my directions are a little different because it says solve for x at the top, and I don't have any x's in this equation, so I'm just going to solve for m. Sorry about that. I didn't realize I did that. Okay, so let's go ahead and get rid of the parentheses. Here we're going to get 3 times m is 3m, and 3 times a +2 is a +6. Rewrite the plus 10, the equal sign, and distribute here. 4 times m is 4m, and 4 times -2 would be -8. All right, I got rid of the parentheses. Now I'm going to collect like terms. Well, on this side I just have a 3m, but I do have these two, which I can add together. Those are like terms. I get a +16 equals 4m minus 8. Okay, now you can move your 4m. I'm going to go ahead and move my 3m just to keep it positive. So I'm going to move 3m to the other side, and I get 16 is equal to m, because 4 minus 3 is 1, minus 8. And then my last step is add 8 to both sides. So I get m equals 16 plus 8, that's going to be 24. I found my m. So these are the kinds of problems that you might see similar on your quiz today. So for your quiz, make sure you put your cell phone in your backpack, and then put your backpacks up against the wall, and then put your folders up, spread out around the room. You can write on the quiz, show all your work, and you may use calculators. So good luck on your quiz, and that's all for today.